Good morning, class. So we're looking at functions. This is our second lesson on functions. Let's go at the back. Let's go. So I gave you homework. It was exercise 7.1. We've done it already, no? So this is actually our third lesson on functions. Okay. Then we went on to 7.2. We completed that as well. Now we're on 7.3, correct? .3. Any issues with 7.3? What was the issues with 7.3? Sorry? Number one. Number one says, what in number one? Hi, morning. Kumalo. She's looking for you. She's looking for you. Kumalo. Mbali. She went to look for you because she took the wrong bag and you got her bag. Now leave her bag here. There we go. So the question here was to use your gradient intercept method to draw the graph on the same system of axes. Okay, so if you look at these graphs, let's get this out here. The exercise 7.3 on page 145. So if you're looking at the gradient intercept method, let's just get an axis quickly. So just looking at the first graph, what was the equation of the first graph? Y is equal to fx equals x. So your gradient, what's your gradient of this line? 1. Not so. So the gradient of this line is 1. You remember in the form y is equal to mx plus c. The gradient is 1 and your c value, which is your y-intercept, is 0. Not so. So for gradient is change in y over change in x. Not so. So the rise is 1. We start here, no? That's your y-intercept. The rise is 1 and the run is 1. So is that point into account? You see that? That is 1 and this is 1. You guys understand? So what I do is, once I have 2 points, I can draw my graph. So take a ruler and I draw the graph going through there. We must go through those points. And there we go. Okay? You guys understand? So this is the graph y is equal to x. Okay, I'll draw the next graph. No, did not explain again. So what was the equation of the second graph? Y equals? Y is equal to gx equals 3x. So remember, the gradient is what? The number in front of x, which is 3. What's your c value? C is 0, which is also your y-intercept. Not so. So the cut your y-axis at 0. So for your gradient, it must change in y but change in x. Not so. So the rise is 3 and your run is 1. So there's 1 and 3. Can you see that? So if I run from 0, it will go to 1. And if I rise by 3, it will go to 3. Can you see that? So it's my run, my rise and my run. How do I know if it's positive, the graph is increasing? Because it's positive. If the 3 had to be negative, the graph would have been decreasing. You understand? So it must go through that point there and it must go through that point there. Okay? You have to get into account. Go through this point and this point here. Again, I take my ruler and I rule the line going through those points. Okay. That is your graph. Remember, this was labeled f of x. So we put the f here, and this remain labeled g of x. I put the g. Can you see that? What is in the equation of the next graph? H of x probably. H of x. They could have used anything. No? This is the order that is normally used in. H of x is equal to? Sorry? X over 2. This is the same as r of x. Not so. So what's my gradient of this line? What's my c value? 0. So this is delta y over delta x. Change in y over change in x. So the rise is 1 and the run is 2. Let's go starting at 0. So y-intercept is 0. You rise by 1 and the change in x by 2. So it has to go to this point 2 and 1. Okay? So again, take my straight line. You go through those points there. There we go. And this is the graph of h of x. Do you understand? That is how you used your gradient intercept method. Okay? What's the next problem? With this exercise? Every straight line of y is equal to mx passes through a common point. What is this point? The origin. Okay, it goes through the origin there, with 0 and 0. Choose the correct option for m is greater than 0. The line y is equal to mx slopes up from left to right. Slopes down from. This graph actually slopes up, as you can see. And the upsloping is called an increasing graph. The graph is increasing. When we are reading the increasing and decreasing part of the graph, we always read from left to right. So, if they ask you, how do you know the graph is increasing? The answer to that would be, as x increases, the value of y increases. Is increasing. Not so. As x increases, as you move from left to right, as x increases, the value of y increases. Okay? Let's look at the next question. So the question is, choose the correct option. So that means to say the gradient is positive. The graph will slope up. Okay. Which of the three graphs is the steepest and which one is the least steep? So which one is the steepest? G of x is the steepest. Can you see it? And the least steep is h of x. So as this gradient increases, the graph becomes steeper and steeper and steeper. As this gradient becomes smaller or closer to 0, the graph becomes less steep. Okay? You all okay with that? Number 2, use a dual intercept method. Okay? So I'm going to use a dual intercept method quickly. Or do you guys have no problems here? Is there a problem here? Huh? Who had a problem here? Who didn't have a problem here? Nobody did homework. So you must either have a problem or you should have had no problem. When I ask you if you had a problem, nobody put up your hand. If I ask you what you had, no problem, nobody put up there. So, okay. Sketch graphs, restricted domain and finding the equation of the straight line. So, that's your next sub-menu. Okay, we're on page 147. The example on page 147. Okay, so sketch graphs, restricted domains, and finding the equation of the straight line. Okay. The question says, draw a sketch of y is equal to 3 minus x with the domain minus 3 and 0. Okay. So when we look at this graph here, there's many ways of doing it. Okay. It's either you draw the graph first, and then we cut off what is needed, what we cut off and erase what is not needed, or we just take a few values on this graph. The question says, draw a sketch of the graph y is equal to f of x equal to 3 minus x with a domain negative 3 and 1. So if it says with a domain negative 3 and 1, what does that mean? What is domain? Or possibly x value. So here we have the restricted domain on this graph. Normally when we have if we had to draw the graph y is equal to minus x plus 3, so to cut at 3 and x value at 3, then there's my graph. Not so. But what is the domain of this graph? As you can see, this graph goes to negative infinity and it goes to positive infinity on x. Can you see that, people? If this is the case, then your domain of this graph is x is an element of all real numbers. That means to say that all the values exist for x here. Can you see that? What's the range of this function? The range is all possible y values. Can you see this graph goes to negative infinity, positive infinity? Can you see that? So you say y is an element of all the real numbers. Can you see that? But now, they are restricting the domain here. So in other words, I must go from -3 on the graph to 1 on the graph. So it's only this part of the graph you're going to draw. So as I indicated before, there's a few ways of doing it. This is one way. So then we just take out what we don't need. Can you see that? So there's the graph. That's one way of doing it. Okay? Otherwise, what we can do is we can say, okay, we all know it's a straight line graph. Yeah? How do we know that? Because it's in the form of y equals mx plus c. Not so? So if I draw this graph, so what I do is, I say, okay, the graph starts going from -3. So f of -3 is 3 minus -3, which is 6. Then I choose another value, f of 0. So that's going to be 3 minus 0, which is 3. Then I choose the endpoint. So importantly, I choose the endpoints. Okay? Then the next one is going to be -3. F of 1. So it will be 3 minus 1, which is 2. So the ordered pairs I draw is -3 and 6, 0 and 3, 1 and 2. Those are the 3 points. Can you see that, people? So taking these points or this ordered pair into account here, you say, okay, let's copy the... Going to -6 and 6. The axis is not big enough. So if I take those points into account, the first one was so the first quadrant was -3 and 6, which is there. -3 and 6, and then I chose 0 and -3 and 1 and 2. Okay. So if we draw this graph, okay, there's just something else I need to highlight as well, but I'm going to draw the graph first. Over here. Okay, so the graph is stopping here, not so. So if we draw that graph, okay, you see there's a block bracket there. I don't know if you guys remember what we said about the block bracket. The block bracket means to say inclusive. So I'm going to make a note here. Block would indicate that it's less than or equal to or more than or equal to. On your number line, it's denoted with a closed circle. You guys remember this from chapter 1, no? The equation, sorry. Then, if it's an open circle, it will have a curved bracket. Or in your inequality notation, it will be more than or less than. Just make that note there quickly. So on the number line, on the number line, and included will have a block bracket in the interval notation, and in your inequality representation of that would be an equal sign if it's more than or less than. It will be more than equal to or less than equal to. If it is excluding, which is an open circle on the number line or on the graph, it will have a curved bracket. Okay? Or more than and less than. So that is excluding. But coming back to what they have here. What do they have here? The 3 has a block bracket. The -3. Can you see that? So here it will be closed, not so. And at one end, at one, it has a open bracket and a curved bracket, so it will have an open circle. That's how we do that. Okay, you guys understand? Then in B they ask you, what is the range of the graph? So range is all possible y values. So we always read it from negative y to positive y. If we read domain, we read it from negative x to positive x. Can you guys understand? So you go from negative y to positive y. Your domain is from negative x to positive x. So we always read it from left to right. Okay? Or we read it from bottom to top. You guys understand? You're dodging the sun. Why don't you just sit somewhere else? Is there 12 seats open somewhere else? You want to sit here. So now you're moving and you want to distract me now. Just sit there. You close to the board. There we go. People, the range is all possible. Y values. So, does this graph exist here at negative infinity? Right at the bottom? No. Where does this graph start existing at? At this point of 2 here, not so. Up until which point does this graph exist? Up until the point of 6. Can you see that, people? So it's between 2 and 6 that this graph exists. You will understand. So in other words, if I write this is as an interval notation, it will be that your y is an element of 2 to 6. Now, would 2 have a curved bracket or a block bracket? Why block? Is it including at 2? No. So it must be a curved bracket. 6 including curve or block bracket? Block. Why? Including 6. Can you see that? Or I could have represented it in inequalities as inequality. Y must be greater than 2 but less than 6. So would I put the equal sign at the 2? No. Why? Because that's excluding. Would I put the equal sign at the 6? Yes. So there we go. Okay. In the next example, they ask you to calculate the equation of the straight line going through those points. Example 2 on 147. But we did gradients not too long ago. Did we do analytical geometry? Yes. So you know how to do this question. Not so? So I'll go straight into it. So the question says, in example 2 on page 147, calculate the equation of the straight line through negative 2 and negative 1 and 1 and 2. So how do you calculate the equation of a straight line? How do you calculate the equation of a straight line, people? Y equals mx plus c. How do you calculate m? y2 minus y1 over x2 minus x1. So the gradient, so you make this x1, that will be y1, x2, y2. So it will be 2 minus minus 1 over 1 minus minus 2. So that's going to give you 3 over 3, which is 1. Not so? The equation is y is equal to 1x plus c. So in pursuit of calculating c, I'm going to substitute one of the values in. One of the coordinates, sorry. So I'm going with negative 2 and negative 4. Remembering that is a x and a y. So negative 1 is equal to 1 into negative 2 plus c. This is negative 2, you bring it over, becomes minus 1 plus 2 is c. So c is 1. What's the equation? Y is equal to x plus. Any confusion there, people? Any confusion? No. Right. So for homework, I would like you guys to do exercise 7.4. We do number 1, number 2, and number 3. We look at exercise 7.5 now. Just cut this for the... Please do it, and I can explain to you what's going on here. No? For the sums that you don't understand or you got it wrong. Okay. Yes? Yes? Sorry? You want to use one or clean one? The used ones is only used on the inside. You can use the outside of the tissue. Huh? Just joking, no? Tell you Mara, I'm telling you, use tissue. Right. So now we're looking at exercise 7.5. The function y is equal to f of x equal to x squared is called a quadratic function. The question is you must calculate the values of. Okay. So what you're going to do is this here. This is on page 150. It's on page 150. Okay, exercise 7.5, page 150. We are told the function y is equal to x squared is called a quadratic function. They ask you to calculate the values of. This is the same as we normally do when we're working out a table. Okay? When we're working out the table. So this is x and your y. My x values they're choosing is negative 3, negative 2, negative 1, 0, 1, 2, and 3. Not so. So what I would like you guys to do now at this point is to draw the table and you calculate the corresponding y values. How do I do that? I substitute negative 3 into x squared. I get 9 and so on. You guys know what to do? Yeah. Right, do that quickly. Pause the video at this point. Alright, so let's look at this here. So 2 gives us, negative 2 gives us 4, 1, 0, 1, 4, 9. You all agree with that?
Yes.
Now it says plot the points. So which points am I going to plot here? Negative 3 and 9. Then negative 2 and 4. Then negative 1 and 1. Then 0 and 0. Then 1 and 1. Then 2 and 4. Then 3 and 9. So plot that quickly on a Cartesian plane. Okay. You guys done? No? Okay. I'll give you a chance. Pause it again. Alright, so at this point we're going to connect the dots. From the turning point, we go. Going through that point there. And of course, the side of the middle. Whoops. Try again. Going through those points. Okay. And there we go. Okay, the board is not 100%, it's not aligned well. That is why I'm going through the dots, but it's not picking it up. There we go. On the side. So I must realign the board, but I'm not going to do it now. So there we go. Not so. But I use a program to draw the graph. I'll show you what the graph looks like. So we have insert a function. We're drawing the f of x squared graph. I don't know why the thing is pausing every time. And there we go, there's the graph. Can you see, people? That one and this one is the same graph. Can you see? Now you see it, now you don't. But you guys understand? Alright. And you see the smooth curve. Okay, and that is the y is equal to x squared graph. Okay. So let's look at the next question. I'll put in my charger before we're in the dark. Ne? Right, so is this something I need to do? Did you guys see it? This part of the graph. What do you notice? I'm going to use this graph here, ne? Because this is a better representation of actually what's happening here. Okay. Just copy that, paste it here. So we don't have to worry about not having that in now. As I. So let's look at the next question. The next question says if the domain of f is a set of real numbers, what is the range of f? Okay, so this is the question there. If the domain of f, what is the domain? All possible x values. If the domain of f is a set of real numbers. So if they didn't tell us that, and they asked us to work out the domain and the range, the domain would have been x is an element of all real numbers. Why? Because this graph goes to negative infinity and positive infinity. You see, these graphs has arrows on them, which means to say those are. Well, what does this arrows mean? The graph is carrying on the negative direction and the positive direction. Not so. So that will go all the way to positive infinity, negative infinity on your x, and it goes to positive infinity on your y. Not so. So if they ask you for the domain of this graph, the answer is x is an element of all real numbers. Okay. But if they ask you for the range, does this graph exist at negative infinity on your y? Does this graph exist at negative infinity on your y? No. Where does it start existing at? It's existing from 0 onwards. Not so, people. So if I have to write, if I'm asked to write down the range of this graph. So what is the range of this graph? Y has to be, is this more than or less than 0? Okay, y has to be more than 0. Does this graph exist at 0? Yes. So y is equal to 0 as well. You guys understand? The next question. The graph of the given quadratic function is symmetrical about a straight line called the axis of symmetry. Okay? We told let's pull this down a bit. The graph of the given quadratic function is symmetrical about the straight line called the axis of symmetry. What is the equation of this straight line? Now remember in primary school, we always spoke about lines of symmetry. Not so. Your body has how many lines of symmetry? Some of you don't have lines of symmetry. What's wrong with you? You must have the line of symmetry. So we got you. This is now you guys, no? Alright? Your line of symmetry, of course, line going down like it. Not so? Yes. So basically, that's on the one side, it's on the other side. No? Then we spoke about squares. How many lines of symmetry are there? So 1, 2, 3, 4. I get 4. And so on and so on. How many lines of symmetry are there in this equation? This one. 1. And where is that line of symmetry? It's a line going through down here, which is the y-axis. But read the question. Okay, why is that the line of symmetry? Because what's on the left of the line is the same that is on the right of the side. But coming back to the question, what did the question say? What is the equation of this line? So what's the equation of your y-axis? X is equal to 0. That is the equation of the y-axis. We just get the last question. Then it says here. The last question says, for which values of values of x is f of x equal to 9 over 4? Confirm your answer algebraically. So if you're looking at 9 over 4, so that f of x is a y value. Not so. So y is equal to 9 over 4. So 9 over 4 is the same as 2 and a quarter. So y is 2 and a quarter. It's approximately there. will come to some value here, which is probably negative 1.5. And it can go this way, which is 1.5. Not so. So I would go with x is equal to plus minus 1.5. Can you see that people 1.5 is 3 over 2? But they want you to confirm it algebraically. So what do is if I say f of x is equal to 9 over 4, what is f of x? X squared. Can you see that people? How do I get x on its own? Square root. If I introduce square root, what must I not forget? Plus minus. So x is equal to plus minus 3 over 2. Can you see that people? There we go. For homework, I want you guys to do exactly the same as what we did here. However, it is on this graph I want you to draw it. Y is equal to 3x squared. That's the one graph. Let's keep it small. 2x squared. Okay, and y is equal to negative x squared. You draw a table. You use the same values that we used before. Oh yes, let's do another one. This is very important for tomorrow's lesson. Because I see some of you are not doing your homework. No? It will give you a better understanding of what is to come tomorrow. Okay? Those are the 3 graphs I would like you guys to draw. All 3, you're going to use a table. And the values you use is from x ranging from negative 3 going to 3. As we did in the previous one. Okay, what's your question? You want to tell me nothing? Huh? Okay. People, you guys got it? Yes. So everyone want to take a photo of this? You all got it? Okay. People enjoy the rest of your day. Good morning, class.